All right, this is the last lesson of Unit 8 for this year's Algebra 2 class. In my classes, we're going to do solving rational equations and inequalities. This lesson is technically more difficult than the last lesson, I would say. However, you might not think it is too terribly bad because we've been practicing the material that we're gonna do in this lesson, and so we'll see. Let's dive in, jump into some examples, and you can let me know whether you think this is difficult or easy or whatever else. So we are going to solve this thing for x, and you have to check your solution. It is important to note that you do need to check your solution. I know sometimes we all get a little bit lazy and don't always check our solutions when we do equations, but it is very important that you check these because sometimes the equation will throw an erroneous solution and there isn't any real solution to the problem. So what are we going to do with this? Well, let me first start by copying this down below so that I can manipulate it and write stuff around it and all of those things. So we're going to do this a lot like, what we did with combining or adding or subtracting or whatever else. We've got all these fractions. We're going to first murder the fractions and kill them, right? And what we're going to do with that is we're going to use our old friend, the least common multiple, or in this case, in all of this unit's case, it might be better to say least common denominator, right? And so that is what we're going to do here. So we're going to do with a big old fat bracket here and we're going to write out our least common denominator for this. So just like when we were adding rational expressions, we kind of split this in our mind into two different pieces. So there's the scalars, the just a numbers like the 6 and the 18, and then there's the things with accents, the expressions. Or I don't know, my words are failing me this afternoon. I keep stuttering over words. But anyway, so when we look at 6 and 18, what is the least common multiple between 6 and 18? So I like to start when I do this, kind of a tip here is I like to look at whatever the biggest number is and think, can I multiply the smaller number times something to get the bigger number? I can, because 6 times 3 is 18, right? So if that's a thing that is true, then the least common multiple between these numbers is just the bigger number. So 18 in this case, right? And then times, and then any expressions we have, we're just going to list them all, right? We don't have to duplicate them unless they're in the same fraction. So x plus 3 there. Then we're going to just multiply this times everything, which is going to cancel out some of the denominators. So in this first one, what's going to cancel? Well, the x plus 3 is going to cancel. So what is left over in our least common denominator? It's 18. So I'm going to write this all the way out, right? So 4 times 18. So there's no regular just number in this one, right? So it's got to be all of 18, right? Now this one, what do we not have? Well, we don't have 3 because, why do we have 3, right? We have 3 because 3 times 6 equals 18. So what are we multiplying here as far as just the number? It's whatever we would need to get to this least common multiple. Oh, that's my wife. Let me pause. All right, where were we? So we're going to write down plus 5, right? Why is it plus? Because of this plus right here. And why is it 5? Because of this 5. Here, the 6 is going to cancel. And if you want to think about what number to put, basically you just take this least common multiple, least common denominator, and you divide it by this number. And whatever you get for that is what you'll multiply there. So in this case, we're going to multiply times 3, because 18 divided by 6 is 3. And then times, now it doesn't have any of this, so we've got to put all of that. So x plus 3, right? And then equals 23 times, now what's left? 18 goes into 18 one time, so nothing there, but it doesn't have the x plus 3, so we've got to put the x plus 3. Oops, that's not an x. x plus 3, right? So now we're going to do some cleanup. It's going to get pretty straightforward at this point, right? 4 times 18 is 40 plus 32, 72. Plus 15. I'm going to go ahead and walk this out in an extra step. We could maybe combine steps, but let's not. Easy way to make mistakes. This one we will go ahead and distribute because this one's already set up to do that, right? So 23 times x is 23x. 23 times 3 is 60 plus 6. No, 9. Almost made a mistake. So plus 69. Okay, so what can we do now? Well, let's distribute this. Distribute this there. I may as well, just for the sake of time, since this is all by itself, let's subtract 72. No, let's not do that. There's no reason to, because we're gonna have to do this one anyway. So yeah, let's not waste our time with that. 72, 15 times x is 15x. 15 times 3 is 45. Equals 23x plus 69. So let's combine like terms over here. We've got 72 and 45. Let's combine those. 72 plus 45 would be 110 plus 7, 117. So we've got 5x plus 117 equals 23x plus 69. Now this, we've been doing kind of combining these type of things for ages now. So let's subtract 23x from both sides. And let's subtract 117 from both sides. You could do it the other way around if you wanted to keep positive numbers, right? I just like to move the variable over to the left. It's just kind of how we roll around here typically. All right, so 5x minus 23 would be negative 1 and 18. 18x equals 69 minus 100. I don't feel like doing that in my head. Let me pause and pull up my calculator. Okay, here we are. So we're going to do 69 minus 117, negative 48. Negative 48. So let's divide by 18, or by negative 18. I'm just going to divide by 18 to remember that I've got a negative divided by a negative, which will give me a positive. So it's not negative 2 2/3. It's positive 2 2/3. Positive 2 2/3, or you might get 8/3, or you might get approximately 2.7, right? Any of those might be the right answer. So we need to check this to make sure it's correct. And so let's chunk it in the thing. All right, so just kidding. I knew that I had probably made a mistake because I didn't think this first example should end up ugly. So this is wrong. Did you catch the mistake? I figured it out. For some reason, I said 15x times x is 5x, so that should be a 15. That should be a 15, which would change this number to 15 minus 23, which is 8, negative 8. So x, in fact, equals positive 6. So let's check that. So we're going to chunk the 6 in here and see what we get. I don't want to make a new swatch. Thank you. So let's do a check. Check. And see if it works out. So 4 over 6 plus 3 is 9 plus 5/6. Does that equal 23 over 18? 4/9. I'm going to go ahead and reduce 4/9 to 2/3, which would turn into, no, that doesn't turn into 2/3. How about I don't do that? How about I just put 4/9 plus 5/6 in the calculator and see what happens? Instead of futzing around over here with middle school math. 4 over 9 plus 5 over 6 equals that. 23 over 18, so it checks out. Great. So our answer for that example is 6. Let's do another one. We have 3 total examples that we're going to do here. So we got a craziness. We kind of have like upgraded a lot, right? So what do? Well, we've got things that look like it can be factored. So almost certainly that is a good first step, is to factor the numerator and factor the denominator. Actually, that's exactly what I'm going to do. I'm going to, I was going to just copy this down here, but for the sake of space and all the things, I'm going to rewrite this, but I'm going to go ahead and factor the top and bottom and put it that way, because that's what we're going to do anyway, right? So 2x over x plus 5 minus, now let's factor the top. So 2 sets of parentheses, open, close, x times x gives us x squared. What about the middle here? What are our options? Well, 10 and 1, 5 and 2, neither of which are going to factor. So let me make sure I copied right before, and then if I did, this top one just doesn't factor. Okay, so I did in fact copy it right. So in this example, the top doesn't actually factor. That's fun. You're like, it doesn't sound fun to me. Well, maybe. We're more interested in the denominator factoring. So hopefully that's going to factor. Because if it doesn't, then we're just going to have a bunch of ugliness. All right, so the denominator, let's try that. Open, close, x times x gives us x squared. What are the factors of 15? Those are equally as simple as 10, different numbers, of course. So we've got 1 and 5, and we've got, not 1 and 5. I don't know why I keep insisting on turning 15s into 5s in this video. I don't know what's happening. We've got 3 and 5 and 1 and 15. I think 3 and 5 is going to work, right? Because 3 times 1 is 3. 1 times 5 is 5. 3 plus, positive 3 plus 5 is 8. Plus. It totally works, right? No big deal. So let's keep going. 3 over x plus 3. So this time we don't have any scalars, any just numbers, right? So let's go ahead and write our least common multiple, least common denominator. Is we're just going to list all the things. Now, x plus 5 we're going to list from this one. This one already has an x plus 5, so we're just going to add the x plus 3. Now, I said this earlier. If this down here was x plus 3 squared or something like that, then we would have to have 2 of them up there. But unless it repeats in the same fraction, you don't have to repeat. You don't repeat them. You just list them once. Right? So I wouldn't list another x plus 3 for this one, right? Because we already have an x plus 3 for that one, right? So there is our least common denominator. So in this first one, the x plus 5 cancels with this x plus 5. So what's left from the least common denominator? Just the x plus 3. So this first bit here is going to be, I'm going to start writing this kind of over so that maybe we'll have room for the check on the same page. We'll see what happens. So 2x and then times x plus 3, right? And then minus, and then all of this mess. I think I got overly ambitious. Maybe I'll just move a lot over and then move it over once I have it in a good place. Minus all of this mess, x squared minus x. Now, where did the parentheses come from? Well, it came from the fact that this minus applies to this entire fraction, so I got to remember that it's going to distribute, right? You could actually distribute it now and then do something later. Now, what cancels in the denominator? Well, everything cancels. So we're not going to actually multiply it times anything except the negative in a minute, right? To distribute that negative. Well, that's nice. Equals, now this one, the x plus 3 cancels with that x plus 3. So what is left? Just the x plus 5. So it's going to be 3 times x plus 5. So this is, I don't know why I did that. x plus 5, right? So this is not quite as ugly as it looked like it was going to be. You might be saying, well, it's still pretty ugly, and maybe you're right, but it's not that bad. It's not that bad at all. All right, now we've got it moved into the right place. So let's take and see what we can do. Well, we're going to distribute here. We're going to distribute the negative here. We're going to distribute this 3 over there, right? So 2x times x is 2x squared. 2x times 3 is 6x. This one's just going to flip all these signs. So we've got minus x squared plus x minus 10 equals 3 times x is 3x. 3 times 5 is 15. All right, so now let's clean up the left side first, and then we'll see how to get what we're going to do after, right? We got like all kinds of things happening. We've got these like terms and these like terms. Anything else on the left side? No. Okay, so 2x minus x squared. Remember, if there's nothing there, there's that little invisible 1 right there. So 2x squared minus x squared is just x squared. 6x plus x is 7x. 7x. And then just bring down the minus 10 equals 3x plus 5. Okay, so we've got a quadratic we're going to solve. We're probably going to have 2 solutions, unless we have to throw one out or something. We shall see. How are we going to solve it? Well, hopefully it factors. So either we're going to factor it or we're going to use the quadratic formula probably, right? And so either way, we need all of this on this side and 0 over there. So we're going to subtract 3x from both sides, and we're going to subtract 5 from both sides. Cancels over here. So we end up with x squared minus 4x minus 15 equals 0. Feel like I made another mistake. Let me pause and see if I did. I did. Did you catch it? Oh my goodness. It should flip all those signs, right? So that should be plus, which would mean this is 5. All right, so let's try to factor this. So it really only has one option because both of these are prime, x squared and 5. So we only have x and x. Well, x squared, is it prime? I don't know. That they both only have one set of factors. That much is true, right? 5 and 1. Can we get a negative 4? We can if we put negative 5 and positive 1. So then we're going to set x minus 5 equal to 0 and x plus 1 equal to 0. And we're going to end up with x equals 5 and negative 1. Great googly moogly. Let's check it and see what happens. So we got to check both of them. Right? So let's check the 5. All right, so we've got 2 times 5 would be 10 over 5 plus 5 is 10 minus 5 squared is 25 minus 5 minus 10 over 5 squared is 25 plus 8 times 5 plus 15. Does that equal 3 over x? No. 5 plus 3. Really, all we're really checking for on these equation ones is does it mess up the denominator? Does that happen? So, you know, all the things which, well, we'll see what happens here in just a moment. 1 minus 25 minus 5 is 20 minus 10 is 10. So minus 10 over 25 plus 8 times 5. I don't know. I don't feel like doing that in my head. Let's chuck that in the calculator. 25 plus 8 times 5 plus 15 equals 80. Does that equal 3 over 15? It's going to reduce, right? So 1 minus 1/8 is 7/8. Does that equal 1/5? It does not. I feel like I've made a mistake. Again, let me see. Because it shouldn't be that much off. It should, but let me see. Oh my gosh, y'all. Oh my gosh. This is the video from annoyingness. That should be a positive 4. I don't know. I don't know. I don't know. I don't know what's happening. I don't know. So if that's a positive 4, this should be a positive 5, and that should be a negative 1, which means our answers, possibly, are negative 5 and positive 1, which messes up all this stuff. Two times negative 5 is negative 10. Negative 5 minus 5 is 0. Oh, it doesn't work. Great. That's what I was expecting to happen on one of them. I didn't remember off the top of my head which one worked. So this one doesn't work because it breaks it. Now, you notice what I've tried to say, and that's I'll make that point again. That really all we're really checking, as long as you've done all your math correct now, it might be worth doing what I did. That way you can catch your just like careless mistakes. But as far as like the required check, we really are just checking the denominator. So like if we put a 1 in here, 1 plus 5 is not 0, right? So that works. If I put a 1 in here, I've got 1 squared, which is 1, plus 8 times 1, which is 8, plus 15, which is also not 0. So it works. And then 1 plus 3 is not 0 because that's 4. And so it all works. Now, again, you might want to do what I did so you can also spit on your microphone and be annoyed at your life that you made a careless mistake. But then you'll also catch the careless mistake. So you may want to go through a full check. All we were really, really checking on is, does it break the denominator? And I know now at this point, based on, what I'm looking at and what I'm looking at over here, this is right. So I'm not going to spend video time doing a full check. But again, you may want to, so you can catch your own careless mistakes as well as just extraneous answers. Let's do one more example with an inequality here, right? So let's solve this inequality. And we're going to, I didn't write check your solution, but we need to definitely check our solution, right? for multiple reasons, right? So let's move this guy right there. There we go. So we're going to find our least common denominator. Big old bracket. We got just a number. Now this time, if I multiply 3 times any whole number, I don't get 4, right? So we can't just use that trick. So what's the least smallest multiple of both of them? Well, that's going to be 12, right? Because 3, 6, 9, 12, neither 6 nor 9 are multiples of 4. So 12 is the smallest one there. And then our expressions, we only have one of them, x minus 2. So now when we multiply this over here, 12 divided by 3 is 4. Put my x right here. So times the 4. Let's do that yellow. I like that plan. Do it like what we did earlier. That way you can see where it's coming from, right? And then does it have the expression? No, it doesn't. So we also need x minus 2, right? And then we're going to bring down this minus. It doesn't have any numbers, so we need all of the 12. So 1 times 12, right, is less than this. We need 3 to get to the 12. 12 divided by 4 is 3. So I'm going to put my, what I started with here. So the x plus 1 from the numerator. And then 3. And then, again, because 12 divided by 4 is 3. And then I don't have any the expression in the denominator. So I need x minus 2. So let's get to work, shall we? So over here, we've got 3x times x minus 2. We can go ahead and distribute that, I think. I don't think that's going to throw us off too badly. This we can go ahead and multiply, right? So 3x times x is 3x squared, and then minus 3x times negative 2 is negative 6x, and then negative 1 times 12 is negative 12, less than. Now, I think what's going to be the easiest is if we go ahead and distribute the 3. We can do it either direction on either one of these. I'm going to just go to the right because we're kind of used to doing it that way, but you'll get the same answer, and it'd be arguably just as easy if you distributed this 3 that way instead, right? So we've got x plus 1 times 3 times x is 3x. 3 times negative 2 is negative 6. Right? So now we've got a big old distributive property, big old FOIL thing, right? First, outside, inside, last. Right? I'm going to bring down all this stuff on the left. 3x squared minus 6x minus 12 is less than x times 3x is 3x squared. X times negative 6 is negative 6x. 1 times 3x is 3x. 1 times negative 6 is negative 6. Okay, so what do we do now? Well, let's combine like terms over here. I don't feel like this should go poof away. So let me pause and make sure I didn't make a mistake. I did make another mistake. Good grief, y'all. This is the trying to do too much in one day. 12 divided by 3 is in fact 4, right? Right. So 4, which will make this a 4 and that a 4. Great. So it's not going to poof away this time, or ever, or whatever. So 4x squared minus 6x minus 12, 3x squared. Negative 6x plus 3x is negative 3x. All right, so we're going to move all this over to this side and leave it equal to 0. Give a shot at factoring it. See what happens. So minus 3x squared minus 3x squared plus 3x plus 3x plus 6 plus 6. So we end up with x squared minus 3x minus 6. So then 0. So let's give a shot at factoring this one. So see what happens. So this, does it factor? X, it doesn't factor. So probably made another stupid mistake. Give me a sec. It's the same stupid mistake. It just affected something else, right? That one, which changes that one, right? Same stupid mistake. Because this would now be negative 8x, because 4x times negative 2 is negative 8x. Negative 8x, which would make this negative 5x. So now this does factor into 6 and 1, negative 6 and positive 1. So our intervals that we are testing, or our places we're testing, right, to see what the range of possible answers are, is negative 1, positive 6, and positive 2. Why positive 2? Why am I chunking that in there? Because we need to also test around the places where it breaks. And again, for rational functions, where does it make the denominator equal to 0? Well, if I put a 2 in here, so basically I'm solving this little mini equation, right? Let me find a totally different equation. So x minus 2 equals 0, and then add 2 to both sides. x equals 2. So 2, so x cannot equal 2 for sure. It definitely can't equal 2. But does that change the stuff? So we've got to now test our different regions here. So let's pick a number over here and try it and see if it works. Let's pick something. And remember, I've said this lots of times in this course already, but if it works for one number in the region, it works for all the numbers in the region. So let's test over here. So we're going to check with a -2. So -2/3. Actually, let's do something that will make that a proper thing. Let's try -6. That sounds good because that's still over in this region, and that's going to end up with a whole number. If you see that, you see that. If you don't, you don't. The check will be the same either way. So we're going to put a -6 minus 2. Is this number less than -6 plus 1? That one's not going to be pretty. We probably could figure out one where it was pretty for both, but we're not going to take all that extra time. We're already making mistakes out the wazoo. So -2 minus 1 over -8. Is that less than -5 over 4? So we're going to add, well, we got to ka-chink that, right? So -2 plus an 1/8 is -1 7/8. -1 7/8. Is that less than -1 1/4? Right? So remembering that negatives, as they get bigger, they get smaller. So yes, this does work potentially. Okay, so x less than -1 is true. Okay, over here is true. Right. So what about in here? Well, we've got our old friend 0. When we have 0, we like to use 0. 0 over 3 is 0, right? Minus 1 over 0 minus 2 is 1 over -2. Is that less than 0 plus 1 is 1 over 4. We ka-chink here. Is 1/2 less than 1/4? So no, it doesn't work right there. What about bigger than 2? So let's try something in between here. How about 3 or 4? That's fine. 4/3. I'm going to write that as 1 1/3. Just because it's seeming like it's easier right now. So over 1 over 4 minus 2 is just 2. So over 1/2. Oh, I wish those were the same denominator. That would be less annoying. And then 4 plus 1 is 5. 5/4, which is the same as 1 1/4. Right? So I should have not done what I did because that's going to be easier to put in the calculator and leave this as 4/4. 4/3. 4/3 minus 1/2. Let's chunk that in the calculator because obviously my brain doesn't work right today. Have y'all had those days? Probably. Which is 5/6. So 1 5/6. Is that less than 5/4? Which is bigger than 1, right? And so, no, it doesn't work here either. So what about the 6 bit? All right, so let's try 7. So 7 over 3 minus 1 over 7 minus 2 is 5. So 1 over 5. Is that less than 8/4 or 2? Okay, so again, we're gonna just put this side in the calculator just because we don't trust me right now, right? I don't trust my brain right now. Do y'all trust my brain right now? Probably not. is a fraction. 32 fifteenths. Actually, I'm going to do it as a mixed number. 2 and 2 fifteenths. So is 2 and 2 fifteenths less than 2? No, it is not. No, it is not. So, did in fact make a mistake again, because, you know, of course I did. This does work. 5/6 is less than 5/4. So that does work. So, oh my goodness. What do we got going on here for an answer? So if we're going to write our answer in interval notation, which I think is going to be good because we've been practicing that this entire course, we've got negative infinity to 1, negative infinity to 1. That's a negative 1. And or union 2 to 6. 2 to 6. And it's not including any of them. Because this is not equals there. So we definitely wouldn't want to include the 2. And if this was this, then this one right here and this one right here would be square brackets, because we would in fact include the -1 and the -6. But we still wouldn't include the 2 because that one messes everything up. So that is it for this lesson. I am sorry about all the mistakes. I think I've caught all of them. So we've at least corrected our errors. I'll see you in class or in the comment section. Have a good one. Bye-bye.